Let us continue the lesson. I suppose you have reached this stage of the process, and then we want to array the panel, and as I have created the panel as a nested family, so we got no problem in the duplication process or arraying the panel. So I pick array tool, and then I sketch the line on which I want the panel to be arrayed. I will talk about the different models of arraying. For example, one of the types is to specify the distance between the first and second panels. And the next type or model of arraying is to specify the distance between the first panel and the last panel. As you can see, we can choose move to second or move to last. And then we can specify the number. For instance, let me specify the distance between first and second one, like nearly 50 centimeters, and then the number 5, for example. Check this out. But if I define a greater value like 15, there's no limitation. Check this out. Very well. But about arraying, as you know, if I select one of the members of the group, I can modify the member like 8. I select and then I enter 10, so we can control it. But right now, if I maximize the value of height, for instance 3 meters, minimizing the value, check this out. The number of the panels is not associated with the value of height, and it is not being updated. So we should associate the number of the panels to the height. To be able to do this, here in family types, let me check the appropriate number of the panels. We should reduce 4 of the panels or remove 4 of them. 6 is okay. Well done. Here, if I want to make the number of the panels parametric or associate a parameter to the numbers, at first we should use array. And then I select one of the members and I click on the dimensions, run the number. Here, as you can see, we can specify a label. If I open the drop-down list, as you can see, we can add a parameter. If I click on that parameter, then here I can create a new parameter to associate to the number of the panels, so that it becomes parametric. For instance, I name it n as number or number. Very well. And after that, I open family types. I can control the number of the panels, for example 5. Check this out. But I want to associate the number to the height and make these two dependent to each other. Am I right? So I select the height and then I make a copy, and then I want to script a formula, height, divide into, for instance, 40 centimeters. The number is 8. As I told you before, we got 2 models of arraying. Specifying the distance from the first and last and the first and second. Here I can modify the value. First of all, I put it into parentheses, -3. The calculated value is 5. Very well. Apply. But right now, if I maximize or enhance the value of height, for instance 4 meters or 4500, apply, check it out. These two are associated to each other. In other words, number is being updated dependent to the height. Following that, we can associate a new parameter to the first panel, for instance. In order to control the distance between the reference level to the panel, I sketch a reference plane here. I measure the dimension. I select it to create a new parameter. For example, I name it base distance by this way. Okay. Then I lock the reference plane to the panel. Check this out. Since they want the distance between the reference level till the first panel, if I open family types, I modify base distance 50 centimeters. Apply, check this out, or 60. Watch this. Apply. I can control the distances. The distances between the panels is minimized to be able to compensate the lack of distance at the bottom. I want you to watch this part carefully. Here, if I specify 800. Here, when the first and the last panels distances till the reference plane are fixed, the distances between the panels are changing, which are reduced. I got a question. Please give me your attention, since we got a lot to do with array parameters. At this moment, some of you may are wondering about the different types or the different models of the placement of the panels or how to distribute the panels. Actually, there are many types of distribution here. For example, if I want to keep the distances between the panels fixed, what should I do? Or how can I only, for instance, control the distances between the panels? Or I may want to make the distances of the first and the last panels to the reference planes equal to each other. These are the types of the distribution of the panels that we can handle them by using parameters. So these were just some subjects or some cases. You can take your time to practice on them. Right now I want to keep the distances between the panels fixed while I'm changing the base constraint or the base distance actually. For instance, I think there is 40 centimeter offset between the panels. I sketch the reference planes. But before that, let me align the reference plane with the another side of the panel or the top surface, not bottom. Well done. And after that, I pick Align tool. Then I align the reference plane with the top surface of the panel. So there is an offset between these two panels that we can control it by using parameters. And if we modify it, it affects on the other panels too. As I did lock the reference plane to the panel, I'm allowed to modify the distances between the panels. So I measure the distance and then I associate it to a new parameter. By this way, I create a new parameter in order to control the distances between the panels. For example, I name it between distance. Right now, watch this, because I'm gonna show you interesting things. I open edit types and then in between distance, I modified 50, for example, 50 centimeters. Check this out. It affects on the number of the panels too. Right now the distance is 500 millimeters. Let me check the base distance, which is 800. I wanna modify it. I want you to keep your eye on the value of between distance while I'm modifying base distance. I specify 500. Check this out. Between distance is fixed. If I set 700, still the value is fixed. So we got two parameters, one between distance for controlling the distances between the panels, and the another one base distance control the distance between the reference level and the panel. But I'm gonna modify the formula which is defined for number, since there is no association between the number and the between and base distance. I modify it. First of all, I want to subtract the base distance from the value of height. By this way, base distance, and then I'm gonna divide the result into between distance, between the panels. By this way, let's check it out, apply. I think here the value of number is acceptable, not bad. Again, I open the family types. Here if I maximize the value of between distance, for example 650, by this way, let's check it out. As you can see, the value of number is associated to three parameters: base distance, between distance, and height. I modify base distance 1200, apply, check it out. As you can see, the number is changed. We got a new set of the panels. You may want to add another panel at the top of the lateral walls, or for instance, you may have other wishes or other ideas to be executed on the number. Let me create a new parameter. By this way, note that there is no limitation here. I name this extra number by this way, and or added number, doesn't make difference. I specify the type integer We got two types of, parameters. We got integer and number. Actually, numbers got fractional parts, but integer numbers do not have fractional parts. As you are concerned, in this context, fractional parts does not make sense. I choose integer. Okay. After that, in the formula of number, I put the whole formula into the parentheses, just because of the priorities in the operations. For example, multiplication and division are regarded as the first priority, and then I add the result by this way. I add it to extra number parameter. Very well, then I click on OK. Right now the extra number is 0, as you can see, or even I can set this parameter as an instance. Maybe it would be better. Okay, actually it is not allowed. Anyway, I click on OK. I wanna modify the value of extra number, for example 1. Let's check it out. Right now, as you can see, it is added to the top, and if you don't want it, you can remove it by specifying the number 0. Okay, let's check it out. So by the parameters, you can control the families. If I open 3D view, this is the result. So during this process, I taught you how to array the panels, or in other words, how to duplicate them by using array tool in two ways. Firstly, you can use array by using the ordinary tools like move to second and move to last. And in the second approach, I created some parameters, for example like distance, base distance and between distance, in order to control the number of the panels. And I'm gonna tell you the third type of the panel distribution. In the third type, I want the first and last distances to be equal to each other. Even I can use conditional formulas. That in the continuation, I'm gonna tell you another way of the distribution of the panels by specifying a formula for the number. I delete the panels and the dimensions. I ungroup these. I keep base distance. Well done. Following that, I sketch a reference plane right here at the top. Then I measure the distance between these two references. I associate the dimension to base distance parameter. Right now, the top distance and base distance are equal with each other. I select the extrusion to pick array tool. This time I want to choose move to last. Then I place the last panel right here on the reference plane, and I define the number 4. Well done. Let me lock the reference plane to the panel by this way. What is happening right now? I open family types. If I modify the value of base distance, like I can set 500. As you can see, the base and top distances are equal to each other, but the distances between the panels has maximized. The number is not parametric. I associate number to the parameter. Let me add a new one. I name it number of last, for example, and last, since the first panel and the last panel are dependent to each other. I open family types to modify and last. I want to define a formula. For example, I make a copy from height, I paste it there, or even I can make a copy from the previous formula, which I defined for number. Control C, Control V. But I modify the formula. For example, I remove the between distance. Then I can specify another value instead of between distance. For example, 40 centimeters. Let me change it. Let me check it. There's a problem here. I add a parenthesis. Correct. I click on apply. Let's check it out. Let me check the numbers. The number is high. I should increase the value. For instance, I set 660 millimeters. 600. Check this out. Or 800 millimeters. Apply. This is better. I open family types again. And right now, if I modify height like 30 let's check it out. As you can see, the parameters are associated to each other, and the value of height and also the number are matched with each other. Check these 6 meters. But did you get the difference? For example, if I specify 7 meters for height, check the distances between the panels. As you can see, the distance is changing, it is maximizing, while in the last type of distribution, the distance between the panels were fixed, while at this type, the distance it is being adjusted. But later, I will talk about the conditional formulas such as if. So at this model, you can consider the distance between the panels as a variable. Here in family types, as you can see, the result is divided to 800. So the distance between the panels will be at least 80 centimeters. If I specify 40 centimeters, check this out. Let me measure the distance. As you can see, it is 40. I open family types. I set 8 thousandths for height. Apply and OK. Then I measure the distances between the panels. As you can see, 38. But how it is being calculated, the value or the number or the distances, it refers to the defined formula for n last and also for the number. Here the n last is 19, which is already rounded. This parameter as a integer type gives us rounded values. For instance, it's rounded, for example, 18.8. And 18.1 will be rounded to 18. So if it rounded to the lower value, it increases the distance between the panels, for instance more than 40 centimeters. But if it is rounded to the higher value, it decreases the distance between the panels. So there is a small tolerance between the specified value and the actual value. The tolerance would be at most 20 centimeters, which is half of 40 centimeters as we specified in the formula. And this is all because of the fractional parts of the values, which are rounded in the integer values. But about the openings and the panels, let's check it out and create something or do something with the holes. Maybe we could create an creative object. At this condition, just like the panels that we created in a separate file and then load it here as the nested family to use it inside the existing family, I do prefer to create a column which passes through the holes or the openings, but I want to create this column as a nested family and then load it here. As I told you before, creating nested families and then load them into the host families provides us with some opportunities like being able to create some parameters and then associate them. So here all we need is just an element and I wanna create it as the nested family. However, we can model it right here in this project without making it nested. I sketch the circle right here for creating the extrusion. Then I associate the parameter for the radius. I name it R. Then in family types, I'm gonna define a formula that the value of R should be lower than the value of hole radius or the radius of the opening. But we got no access to the radius of the hole. How we can get access to it? Excellent, the edit type of the panel. And if we want to get access to it right here, I should select the panel and then I open the edit type. As you can see, hole R. Here, since I need this parameter, I want to associate it to the other families. I need to create a new one by this way. I can specify the same name, hole R, by this way. Okay. By associating the parameter of hole R to a new parameter, we can get access to it here in the family types. And as you can see, it is added to the parameters of the dimensions. Then let me define the formula for hole R. For the R actually, I'm sorry. The size of the R should be at least 10 centimeters, 1 centimeters less than the whole R. Let's check it out in the 3D view by this way. I can control the height of these by associating extrusion N to the height, then they will be matched to each other. Well done. Right now the only thing which is left is to test the parameters to make sure that if they are working correctly. I open family types, I modify width, for instance 35 hundredths, apply and OK, check this out, the circular extrusion is not matched, and if I modify depth, actually this shows that there is no constraint between the extrusion and other parts of the family. And as you can see, if I modify the values of, for example, edge distance, They got no effect on the position of the circular extrusion. Let me check these formulas. I want to check a problem actually. Let me check the associated parameter to depth, panel depth. Let me check panel depth. As you can see, depth is subtracted from 2 multiple in edge distance, but it still does not work out. At first, let me check the panel. So I open edit type of the nested family or the panel. Let me check the associated parameter to the depth, which is panel depth, which is 570. Let me check the value in family types. Here is 900. This shows that there is a problem here. I want to open the edit family of the nested family. Since there is something wrong here with the panel depth, as you can see here is depth. Let me test the parameter. 1500 for depth. Apply. This is correct. I mean, it is working accurately. Finish. I specify 1000. Apply. Very well. I load it into family 1 by this way. Override. Parameter panel depth cannot be changed because it is defined by formula depth. I select the panel, then I open edit type. Depth is associated to panel depth. Let me check family types. As you can see, the formula is deleted. I don't know why. I'm gonna define it again. I copy width. Then I paste it in panel depth formula. Inside the parentheses, I subtract it, subtracting from, wait for a second, I remove the parentheses, unexpected. I'm gonna multiple 2 in edge distance inside the enclosed parentheses. Okay. If I check family types again, I'm sorry again, I made a mistake. I replace depth by this way. Let me check others. We're finished with panel depth. I select the panel, then I open its edit type. Let me check depth. It is associated to panel depth. I choose none to dissociate it. Okay. Then again, I choose depth to associate it to panel depth. Well done, it is solved. Actually, it was a bug, since sometimes you may have some clashes while you are working with Revit. There are some times that the problem is with the software, however it occurs rarely. Anyway, as I told you before, we should use nested families here, since as I mentioned, I can't lock this or constrain it to a reference plane. And if I want to align it, as you can see, there is no reference planes. There is not a medium. While here, if I create the family in another family template file, which is only a single object, especially a circular one. Let me choose metric generic models, open. The reference planes helps us to control the object or the created family. Check this out, I sketch it, then I associate the radius by creating the parameter. Well done, then finish. Then I associate the family for the extrusion end. I name it height. Very well, okay. And then when I loaded it, I will associate it to the height of the project. I load it. Well done. Just in a few seconds. As you can see, I can get access to the center lines, the reference planes. I select it, then I open edit type. I associate R to the radius, and I associate height to the height of the panel. Well done, we're finished. But right now I need the 1/3 part of the panel, since I want to place the extrusion right here. So let me sketch the reference planes. I measure the distances between them and equalize them. Well done. And also here, equalized. Well done. Right now we got two reference planes which are crossing each other. Let me align the extrusion with the reference planes and locked by this way. Let's check it out. in the 3D view. And as you remember, I have associated a parameter for the materials here in panel. Again, I should associate the parameter so that after loading them into the project, I will be able to modify the material. Well done. Right now I want to load this family into project. Okay, by this way. For instance, I place it right here. I select it. Then in edit type, we got access to all of the parameters. As you can see in dimensions, for example, that can be modified. But the material parameter is not here. I mean, we had everything except the material parameter. But what is the reason? I open edit type again. I want you to watch this part carefully since I'm gonna tell you the reason. Right now, I'm gonna sketch a geometry. So, watch this. Here, suppose this circle as a family. Let me type F, which stands as family. Let me maximize the text size, 50, very well. I place it right here. So this is our family, which contains some parameters. For instance, these are the including parameters of this specified family: width, depth, height, material. We would load it like this to the another project or another family since it is a nested family. I want to show the loading process from a family to the another family. When we load a nested family inside to the another family, the parameters will be transferred within the family. In other words, the parameters are moved or transferred along with the family when it is being loaded to the another family. By this way, as you can see, right now the second family or the host family. Right now inside the current family, we can find the nested family and also its parameters. I'm just trying to show you the process graphically, just like showing them on boards. So here we got the family and the nested family which has been loaded inside to the family. Very well. And both of them have got their specific parameters as well. But after loading these two families into a project by this way, suppose this is a project. Let me type P stands as project in which the families are going to be loaded. When we load this family, which has got the nested family into the project by this way, for instance, only parameters which are associated to the host family will be transferred to the project. As you can see, the parameters which has been associated to the nested family won't be transferred. They are still remained at the host family. And the host family has got its specific parameters. That these families, the nested families, here there are, as you can see, that they are not transferred to the project. But we need them. We need the nested family's parameters. And the material was associated to the first panel or to the created panel. And for having the parameters for the nested families in the project, we have to associate the nested family's parameters to the host family's parameters if we want to get access to them in the project. As you can see, I should associate them one by one for being able to control them so that they will be transferred to the project while loading the whole family. But how can I do this? How can I associate these two to each other? Let me check the views on family 1. Here there is. Here I select the nested panel. As you can see, I open the type properties. As you can see, there is still a parameter which hasn't been associated, T or thickness. Right now, I should associate T parameter to one of the corresponding parameters of the host family. Since when I open the host family environment, you got access to only the host parameters. So I want to associate it to the corresponding parameter of the host family. And if there was another similar parameter, thickness, we should create a new one so that we can associate this family parameter to the host parameter. For instance, thickness panel or panel thickness. Then T will be transparent, as you can see, since it is controlled by T panel. After that, we can control T by here in the family types. So after this process, we can get access to T in the project as well. We got the same process about the material. As you can see, we got panel material, which is not associated yet. Here, as you can see, the family types, the material is not associated. But how do we can get access to it from project? I select the panel, then I open edit type. I associate the family parameter of the material. As you can see, there is no corresponding parameters, so I should create a new one. Then here I name it panel, for example. So by panel I can control the material of the project. As you can see, we got the associated parameter in the family of types so that it will be transferred to the project while we are loading the family into the project. Since the parameters of the nested family were all associated to the host family. And right now if I load it into project, override, I select the family. As you can see, T and panel are added, so we can control both of them. I can get access to the material browser, for instance glass. Check this out. Then we will have glass panels, as you can see on the 3D view. Well done. As you can see on the screen, today's session's topics were all about some basic knowledges about families that are vital to be known, and it is recommended to be watched many times for those who are not familiar with the parametric families. Don't forget to practice the given details, since in the future sessions we're gonna again engage with the told lessons, and I want to assign you a homework. For the distribution of the panels, you can create some parameters in order to control the distances between the panels and also the base offset. Following that, I want the numbers to be well adjusted while you modify the height.